Welcome back to this session. Today in this session, we will be continuing from where we left off yesterday. We will be solving more numerical in this session. Let us start with the first numerical. A bar 25 mm wide and 5 mm thick is 1.2 meter long. It is subjected to an axial pull of 30 kN. Calculate the changes in 1. Length, 2. Width, 3. Thickness, and 4. Volume of the bar. Take E equals to 190 GPa and mu equals to 0.24. अब यहाँ पर क्या फाइंड करने के लिए बोला है? We have to find the changes in its length, width, thickness, and volume of the bar. In this question, there is a bar and वो bar पे force लग रहा है. कितना force लग रहा है? 30 kilonewton force लग रहा है. And कौन से टाइप का फोर्स लग रहा है? ये डायग्राम पे देखो, सेकंड डायग्राम पे here. It is a force that is pulling the material, and this kind of force is a tensile force. Now, when the tensile force acts on a body or any material, it will elongate the body. So as it elongates the length of the material, the secondary length will be decreasing. What are the secondary lengths? Those are width and its thickness. So we will have to find change in its length, change in its width, change in its thickness, and volume of the bar. So what are the things that are given in the question? So here it is given value of E. Young's modulus is given 190 GPa. So if you convert this 190 GPa to Newton per mm square, it will be equal to 190 into 10 raised to power 3. B, width is given 25 mm, thickness T is given 5 mm, and the force P is given 30 kilonewton. So if you convert this kilonewton to Newton, it will be 30 into 10 raised to power 3 Newton, and the value of mu is given, which is equal to 0.24. Now, let us first find the change in its length, del L. To find del L, we can simply use the formula del L equals to PL by AE. Now all these values P, L, A and E, they are given in the question. So we'll put all the value one by one and then we'll find the value of del L. So how much is P given in the question? P given in the question is 30 kilonewton. So converting kilonewton to Newton, we have 30 into 10 raised to power 3 into its length given is 1.2 meter long. So this length here, it is 1.2 meter long. You need to convert this meter to mm, so it will be 1.2 into 1000, which will be coming equal to 1200 divided by, now area of this bar will be equal to its B into T. How much is B? B is 25 and T is 5 into E. E is given 190 GPa, which we have converted into Newton per mm square. So it will be 190 into 10 raised to power 3. So let's solve this in a calculator. P into L. 1.2 into 10 raised to power 3 divided by AE. 25 into 5 into E is 190 into 10 raised to power 3. So from here we're getting change in length is coming equal to 1.515. So the change in length is coming 1.515 mm. So we have found the first condition where they have asked us to find change in length. Now second, we can find change in width or change in thickness. These two, change in width and change in thickness, we find it from the lateral strain. This comes in a lateral strain. This change in length comes in a linear strain. So since we have found del L, हमें del L मिला है, तो फिर यहाँ से हम linear strain calculate कर सकते हैं. What is linear strain? Linear strain is equals to change in length by original length. So change in length कितना आया? 1.515 divided by original length कितना है 1.2 into 10 raised to power 3. So let us find linear strain 1.515 divided by 1.2 into 10 raised to power 3. So this is the linear strain. So linear strain is coming equal to 1.2625 into 10 raised to power 3. So here the value taken here is 1.263. So here in the calculator, as you can see, the value is 1.2625. So here 2 has been rounded off, since after 2 we have 5. So here they have taken 1.263 into 10 raised to power minus 3, and strain has no unit. Now similarly we find lateral strain. To find lateral strain, we have to find lateral strain from the relation lateral strain using the relationship between Poisson's ratio, lateral strain and linear strain. So Poisson's ratio is the ratio of lateral strain to the linear strain. So from that equation हम वो equation use करके lateral strain find करेंगे, तो हमारा lateral strain will be coming equal to minus mu into E. ये क्या है minus mu? It means that since linear strain increase हो रहा है तो lateral strain minus पे आएंगे. So वही इसका मतलब minus मतलब वही है. जब ये length increase होगा उसका secondary lengths will be decreasing. तो secondary lengths किस पे आते हैं? Lateral strain पे आते हैं. So lateral strains will be decreasing. Mu का value कितना दिया है? Mu का value is given 0.24. So we have minus 0.24 into E. The value of E is 1.263 into 10 raised to power minus 3. So this is your lateral strain. So lateral strain is coming equal to minus 3.0312 into 10 raised to power minus 4. So this is your lateral strain here. So lateral strain. Now what is actual lateral strain? Lateral strain is equals to change in B by its original width or change in its thickness by original thickness is the lateral strain. So अगर हम यहाँ पर पहले change in thickness find करेंगे तो lateral strain is equal to change in thickness by its original thickness. और हमें lateral strain कितना मिला है? हमें lateral strain मिला है इतना, right? So put the value of this lateral strain here will be equal to del T by T. T कितना दिया है? Original thickness is given equal to 5 mm. So here 5 mm, we put the value of 5 here. अब हम जब cross multiply करते हैं तो फिर ये जो T है, T lateral strain के साथ multiply हो जाएगा. So it will become minus 3.0315 into 10 raised to power minus 4 into 5. ये करेंगे तो आपको you will get change in thickness. So change in thickness is coming equal to minus 1.5156 into 10 raised to power minus 3 mm. So you have change in its thickness. Now similarly, if we find change in width will also be equal to lateral strain will be equal to change in width by original width. और lateral strain कितना मिला था? Similarly again lateral strain हमें minus 3.0315 मिला था into 10 raised to power minus 4 into its width B. B कितना दिया है? Original width 25 दिया है. So I'll go back into 25. So we're getting minus 7.578 into 10 raised to power minus 3 mm. So this is change in the width of this material here. So now हमें del L, del T और del B मिला है. Del L क्या है? Change in length. Del T change in its thickness. Del B change in its width. Now लास्ट पे क्या फाइंड करने के लिए बोला है? वॉल्यूम ऑफ द बार. वॉल्यूम ऑफ द बार, चेंज इन वॉल्यूम ऑफ द बार कितना आएंगे. नाउ ये कौन से कंडीशन है? यहाँ पर कितना लोड लग रहा है और कौन से एक्सिस से लग रहा है? सिर्फ एक ही लोड लग रहा है एंड फ्रॉम वन एक्सिस ओनली. तो अगर एक ही लोड लग रहा है फ्रॉम वन एक्सिस ओनली तो कौन से टाइप ऑफ सिस्टम पे आएंगे? इट इज अ uni-axial loading. And for uni-axial loading, volumetric strain is equals to del V by V equals to E1 minus 2 mu. Right? अब हमें E का वैल्यू पता है, म्यू का वैल्यू पता है, V का वैल्यू पता है, तो we can directly find del V from here. So अगर हम V को यहाँ पर लेके जाएंगे राइट हैंड साइड पे, तो हम डायरेक्टली V को इधर लेके जाके मल्टीप्लाई कर सकते. सो हियर एज यू कैन सी हियर del V becomes equal to, V को राइट हैंड साइड पे लेके जाया गया, so it will be V into E1 minus 2 mu. अब V कितना है? वॉल्यूम कैसे फाइंड करेंगे? एरिया इंटू लेंथ ऑफ दिस बार. सो एरिया कितना है? एरिया इज 5 into 25 इंटू लेंथ कितना है? 1.2 मीटर. तो 1.2 मीटर को mm पे कन्वर्ट किया तो इट विल बी 1200 इंटू E कितना मिला? E is equal to 1.263 into 10 raised to power minus 3. So we have 1.263 into 10 raised to power minus 3 bracket open 1 minus 2 into mu. Mu कितना दिया है क्वेश्चन पे? क्वेश्चन पे mu दिया है 0.24. So यहाँ पर mu का वैल्यू 2 into 0.24. So अगर हमने ये पूरा सॉल्व किया तो let us see how much we get. Volume is area into its length into E is equal to 1.263 into 10 raised to power minus 3 into 1 minus 2 into 0.24. So यहाँ से आपका change in volume is coming equal to 98.514 mm cube. So this is the change in volume. I hope this numerical is clear. It is very simple. So let us solve the next numerical. So second numerical पे, a cube of 200 mm side is subjected to a compressive force of 3.6 meganewton on each face. The change in volume is found to be 5125 mm cube. Find E and K if 1 by m is equals to 0.25. तो यहाँ पर क्या दिया है? क्यूब दिया है, क्यूब का साइड दिया है, तो एक साइड दिया है मतलब पूरा साइड इज इक्वल टू 200 mm. ओके, एंड सब्जेक्टेड टू कंप्रेसिव फोर्स ऑफ 3.6 मेगा न्यूटन. 3.6 कंप्रेसिव बोल रहा है, तो कंप्रेसिव कैसा होगा? इट विल एक्ट इनसाइड द मटेरियल. सो यहाँ पर एज यू कैन सी हियर from x-axis 3.6 meganewton is acting inside this box. From this y-axis 3.6 is again acting inside, और यहाँ पर z-axis से भी it is acting inside. So तीनों डायरेक्शन से compressive force लग रहा है और change in volume भी दिया है. और यहाँ से हमें क्या फाइंड करने के लिए बोला है? E क्या है? E is Young's modulus और modulus of elasticity, and K क्या है? K is the bulk modulus और Poisson's ratio दिया है यहाँ पर. Let us first convert this force which is given equal to 3.6 meganewton. Meganewton को हम न्यूटन पे कन्वर्ट करेंगे तो it will be into 10 raised to power 6. So here compressive force P is given 3.6 meganewton is equal to 3.6 into 10 raised to power 6 newton. Okay, अब यहाँ से change in volume भी दिया है और Poisson's ratio दिया है. From this given side given है तो we can find the area of this cube, area of this cube will be equal to side square. So side square will be equal to 200 square. So you can also do 200 into 200, which will come equal to 200 into 200. So this is coming equal to 40 into 10 raised to power 3. अगर आप 4 बनाएंगे तो it will be 4 into 10 raised to power 4 mm square. And volume, change in volume दिया है, right? Now let us find E and K. First, let us find volume bulk modulus K. So bulk modulus K, the formula to find bulk modulus K is equals to direct stress by the volumetric strain. So direct stress कब आते हैं? Direct stress आते हैं अगर for any material from all the three directions, same kind of force, if same kind of force is acting, then only we'll get direct stress. So as you can see in this diagram here, from all the three directions, same force is acting. So because of this same force, the stresses produced in this cube will be direct stress. So we have direct stress by volumetric strain. So direct stress sigma is equals to force by area. Force given is 3.6 into 10 raised to power 6 divided by its area is 4 into 10 raised to power 4. So let us find direct stress. It will become equal to 3.6 into 10 raised to power 6 divided by its area. So it is coming 90 Newton per mm square. Direct stress 90 Newton per mm square आ रहा है. Now original volume find करना है तो क्यूब है तो क्यूब का लेंथ वॉल्यूम कैसे फाइंड करेंगे? It will be side क्यूब. So side क्यूब करेंगे तो साइड कितना दिया है? साइड 200 दिया है. तो 200 क्यूब करेंगे तो we'll get volume equal to 8 into 10 raised to power 6. So we have volume equals to 8 into 10 raised to power 6 mm cube. Now volumetric strain find करने के लिए we need to have change in volume by original volume. हमें change in volume question पे दिया है already और original volume we found it right now. So change in volume कितना दिया है? 5125 mm cube divided by its original volume. So this is the volumetric strain which is coming equal to 6.40 into 10 raised to power minus 4 और यहाँ पर दिया है 640 into 10 raised to power minus 6. The value that you are seeing in the calculator and the value that is written here, it is one and the same. Okay, so now since we have found direct stress as well as volumetric strain, we can find bulk modulus K. So the bulk modulus K will be equal to direct stress by the volumetric strain. So it is coming equal to 140 into 10 raised to power 3. So here instead of taking 140, they have taken 0.14 into 10 raised to power 6. So if you go 3 decimal in front, 1, 2 and 3 decimal in front with the value given in the calculator, you will also get 0.14 into 10 raised to power 6. So you can either write 140.48 into 10 raised to power 3 or 0.14 into 10 raised to power 6 Newton per mm square. Okay, now we have found bulk modulus and we have to find Young's modulus. Now from the relationship between bulk modulus and Young's modulus, we can find the value of E. So the relationship between them is given by E equals to 3K 1 minus 2 mu. अब E का value नहीं पता, K का value we have found it, mu का value is given in the question. So it will be 3 into K into 1 minus 2 into mu is 0.25. So this is the value of E. Value of E is coming equal to 210.7 into 10 raised to power 3. Again here they have taken 0.25 21 into 10 raised to power 6. If you move the decimal point in front of 2, you will also get 0.21 into 10 raised to power 6. So the value is same. Okay. So I hope this one is also clear. Coming to the third numerical here. A cube of 200 mm side is subjected to a compressive force of 3600 kilonewton on all its faces. The change in the volume of the cube is found to be 5000 mm cube. Calculate the bulk modulus. If mu is equal to 0.28. Okay, so instead of यहाँ पर the value is given 0.28 here. If mu is equals to 0.28, find Young's modulus. फिर भी यहाँ पर what is given in the question? Cube का side दिया है 200 mm side दिया है, and the force acting on this cube is equals to 3600 kilonewton, and it is acting on all the 3 faces. Okay, now if we have the change in volume is given, we have to find bulk modulus K. Again, the same way we have solved the previous question, we'll have to find it in the similar manner. So K will be equal to direct stress by the volumetric strain. Direct stress कैसे find करेंगे? Direct stress will be equal to force by area. Force, how much is force given in the question? Force is given equal to 3600 into 10 raised to power 3 Newton divided by area. Since it is cube, it will be side square. So this is your direct stress. Direct stress is coming equal to 90 Newton per mm square. Okay. Now next, we need to find the bulk modulus K. To find bulk modulus K, change in volume by original volume is required. So original volume कैसे find करेंगे? Original volume will be side cube. Okay. So let me find bulk modulus now. Since we have found stress is equals to 90 divided by volumetric strain. Change in volume is given equal to 5000 divided by original volume will be equal to side cube. So we'll be getting 144 into 10 raised to power 3 Newton per mm square. So this is the bulk modulus. Now again, using the relationship between bulk modulus and modulus of elasticity, we can find the value of E. So relationship is E equals to 3K 1 minus 2 mu. Since we have found the value of K and we know the value of mu, we can find the value of E. So let us solve directly. 3 into K into 1 minus 2 into mu is equals to 0.28 is equal to 190.08 into 10 raised to power 3. Okay, again if you shift the decimal point 2 times in front and make it 1.9, you will get 1.9 into 10 raised to power 5. So the value that you are getting here in calculator and the value that is written here, it is again same. So Young's modulus is coming equal to 1.9 into 10 raised to power 5 Newton per mm square. So I hope this numerical is also clear. They are very simple numericals. You just have to know what is linear and lateral strain. So once you know what is linear and lateral strain, it will be very easy for you to calculate. Now coming to the last numerical for this session. A cube of 200 mm side is subjected to a compressive force of 3500 kilonewton on all its faces. The change in volume of the cube is 5000 mm cube. Calculate bulk modulus and modulus of elasticity if Poisson's ratio is 0.28. So ये भी similar kind of question है जो हमने पिछले पे solve किया है. तो again यहाँ पर भी we need to find bulk modulus K. Bulk modulus K is equals to direct stress by volumetric strain. So direct stress कितना आएंगे? I'm gonna solve directly here. Direct stress is equals to force by area. Force कितना दिया है? 3500 kilonewton दिया है, तो convert it into Newton. So it will become 3500 into 10 raised to power 3 divided by area. So this is cube. So area will be side square. So 200 square. So this is your direct stress divided by volumetric strain will be equal to change in volume is given equal to 5000. The original volume will be equal to side cube, which is 200 cube. 200 cube. So this is coming equal to 140 into 10 raised to power 3. So again यहाँ पर भी if we move the decimal point 3 times in front, we will get 0.14 into 10 raised to power 6 Newton per mm square. So the value that you are seeing in the calculator and the value that is written here, it is again same. Now again, using the relationship between bulk modulus and modulus of elasticity, we have 3k E equals to 3k 1 minus 2 mu. We know the value of k, so we will directly find 3k into 1 minus 2 into mu is given equal to 0.28. So we're getting 184.8 into 10 raised to power 3. Again, if you move this decimal point 3 times in front, you will get 0.18 into 10 raised to power 6 Newton per mm square. So these are the value. I hope all this numerical is clear. The value of K is found and the value of E is found as asked in the question. I hope this numerical is clear. We'll solve 4 more numerical in tomorrow's session. See you in tomorrow's session.